Okay, my class. Let's continue this integration by substitution. Okay, so this one, it involves the substitution of trigonometric function. Okay, this one. So if your fx, okay, if your fx contains the function in this, okay, in this pattern, okay, where we have square root of a squared minus x squared, a is a constant. Okay, a is a constant. So a squared minus x squared, or x squared minus a squared, or a squared plus x squared. Then we will use this substitution. Okay, now if we look at this, okay, let's say I show you the first one, a squared minus x squared. Why we use this a sine theta? A squared minus x squared. Okay, next we use this. Okay, why we use the sine instead of tangent? Second, okay, because when we have this, okay, x, this is x squared. So when we square the x, that means we square the right-hand side function. Okay, then when we substitute this back into the x here, that means we have a square sine square x. Then we can factorize the a square. Then we get 1 minus sine squared x. Okay, so from here, we know that 1 minus sine squared x is cos square x because we have the identity. Okay, remember this identity? Okay. So 1 minus sine squared x is cos square x. Okay, then we can cancel out the square root a cos x. Okay, the main purpose when we want to use this function for the substitution function, okay, is we want to cancel out the square root. Okay, so for this example, actually, we can either use sine x or cos x. Okay, sine x or cos x, but we don't use cos x because later on, you have the dx, you want to change dx into sorry, this one should be theta. That should be theta. Theta. Okay, so if you have dx here, later on, we will change the x into theta. So to get the d theta, we will differentiate this one. So when we differentiate sine theta, we get positive cos theta. Okay, but if we choose cos theta, we will get a negative sine later. Okay, that's why in between the choices sine theta and cos theta, we choose sine theta when you have this kind of function. Okay, for the integration. Okay, another case, a squared plus x squared. Okay. a square plus x square. This x we need to use tangent theta. Okay, tangent theta because okay, your x square will be a square tangent square theta. Okay, tangent square theta. So this one will be a square tangent square theta. So after the factorization, you have 1 plus tangent square theta. So this one, 1 plus tangent square theta is secant square theta. This is another identity. Okay, that's why we can change the 1 plus tangent square into secant square theta. And at the end, we are able to get rid the square root, okay, with the square. Okay, we want to get rid the square root. Okay, that's why we use this as the substitution. And for the last case, you have the x squared minus a squared. Minus a squared. So for this case, we will use a secant theta. Okay, a secant theta because x squared minus your x squared is a squared secant square theta. So we have a squared secant square theta minus a squared. So after the factorization, we have secant square theta minus 1. So that means we are using the same identity. Secant square theta minus 1, we have tangent square theta. Tangent square theta. So that means after we cancel out the square, with the square root, we have this. Without square root. Okay, that's why we have this 3. Okay, this 3 function. Okay, now we look at the first example. Okay, this one I also write on the board. Okay, 4 minus x squared. 4 minus x squared, and we want to integrate. Okay, so this one, according to the table just now, 4 minus x squared, that means a squared minus x squared. A squared minus x squared, that means we use sine. Okay, we use sine. So we have to let your x to be, what is your a? A is 2. 2 sine theta. Okay, this is how we choose the substitution function. Okay, then we have 4 minus, we want x squared. So x squared is 4 sine squared theta. So we substitute the x squared here by 4 sine squared theta. Okay, next we want the x. Okay, we want the x. So from here, the x d theta is 2 cos theta, right? 2 cos theta. And we want dx. So dx is 2 cos theta d theta. So we substitute this dx by this 2 cos theta d theta. Okay, then simplify. Here we factorize the 4. Factorize the 4, so we have 1 minus sine square theta. Okay, this is still 2 cos theta d theta. Okay, so this is square root of 4 again. I still proceed in this 4. 1 minus sine square theta is 2 cos square theta, right? Identity. Sine square theta plus cos square theta equals to 1. Sine square theta plus cos square theta equals to 1. So 1 minus sine square theta is cos square theta. Okay, this one we change into this. Okay, 2 cos theta theta. Okay, then cancel out the, okay, 4 is 2 squared. 4 is 2 squared. So this square and this square, we will cancel off the square root. So we have 2 cos theta times 2 cos theta B data. Okay, then 2 times 2, we get a 4. Cos data, we have cos squared data. Okay, next, when we want to integrate, okay, we can factorize the 4 first. We factorize the 4, and for the integration of cos square, we need to use another identity. Okay, another identity for this one. Factorize the 4. Then the cos square data. Okay, we have another identity, which is cos 2 data equals to 2 cos square data minus 1. Okay, this is another identity. So cos square data, we want this cos square data. So we rearrange your cos square data will be this one from here, cos 2 data plus 1, and then divided by 2. Okay, so we replace the cos square data by this function, cos 2 data plus 1 divided by 2. Okay, then cancel out this. We have 2 cos 2 data plus 1. That means when we are integrating cos, we get a sine 2 data divided by 2. And plus 1, it will be plus data plus c. Okay, so this 2 cancel out with this 2, you have sine 2 data plus 2 data plus c. Okay, then just now we have x equals to 2 sine data, right? We want to change the data back into x. Back into x. So here we have to use another identity. A number of identity, but these are the mostly used identity. The sine 2 data is 2 sine data cos data. Okay, now we use this sine 2 data. Okay, we have this 2 sine data cos data plus 2 data plus c. Okay, why we change into this? Okay, this one change into this because from here we can have the sine data as x over 2. Correct? X over 2 is your sine data. So sine data is this one divided by hypotenuse. Then what is this? Square root of the square of hypotenuse minus the square of x. So from here, sine theta is x over 2. Cos theta is, what is cos theta?
0.
Cos theta is this one divided by hypotenuse. Right? Then plus 2 theta. 2 times theta. What is your theta? This one, your theta is arc sine x over 2. So this is arc sine x over 2 plus c. So far, I just want you to understand every single steps. Okay, try to understand every single steps.
Ini biasa motor tak?
I don't know. Okay, so this is the process. So I make a summary. When you have this kind of function, okay, we have to choose the correct substitution. Okay, this is 4 minus x squared. Okay, our question is 4 minus x squared. So a is 2. So we have to use 2 sine theta. Okay, 2 sine theta. Then we square the x. Okay, we square the x because we want to substitute this x squared. So we square this, we get x squared equals to 4 sine square theta. Okay, then we can substitute this x squared by this. Then we get this. Okay. Then this one you can further, okay, this one, the working is that they separate the integral with the integration. Okay, so this one, we can factorize the 4, and then we have 1 minus sine square theta. 1 minus sine square theta is cos square theta. Okay, so you have 4 cos theta, which is 2 cos theta. Because of the square root, you have 2 cos theta. Okay, then you have the dx. Okay, here, this one dx. So you differentiate this one with respect to theta, you get 2 cos theta. Okay, 2 cos theta. So we want only dx, so your dx is 2 cos theta d theta. Okay, because I already removed the part just now. Okay, so I can only show you this one. Okay, so after the substitution, okay, after we change all the x into theta, you will get this. Okay, then yeah, the steps are here. Okay, so this one, I think what I write on the board is clearer. Okay. So dx is 2 cos theta d theta. So we factorize the 2 here. Okay, we substitute x squared by 4 sine square theta. Okay, then we factorize the 4. We have 1 minus sine square theta. Then we get 4 cos square theta. After we cancel out the square root with the square, we have 2 cos theta. Okay, so 2 cos theta times 2 cos theta is 4 cos square theta. So for the integration, we can't integrate when you have cos squared or sine squared. So we have to change this one into no power of 1. Okay, power of 1. So we have to use this identity. So you express the cos squared theta as the subject in terms of this one. Okay, then you will get this. Okay, expand, simplify, you get this one. So after integration, okay, simplify, you get this. So at the end, we want to substitute theta back into x. So sine 2 theta, you have to use this. Okay, sine 2 theta, we use this because we want the sine theta. We have the sine theta here. Sine theta is x over 2. And we can get the cos theta by sketching a triangle based on this. And based on this one, we can sketch a triangle and get the cos theta in terms of x. That's why we use this identity to change the sine to theta. Okay, and the last one, theta. Okay, theta, we get the theta from here. Theta is up sine x over 2 plus c. Any questions? Yeah. Oh yeah. Okay. I feel like to skip this one because I'm scared you will, if you feel confused with this one, you will feel even confused with this one because this is more difficult compared to this one. Okay, this one, after you substitute the x by secant data, okay, after you replace all the x into data, you get this one. Then before the integration, you need to substitute, you need to use another substitution to solve this integration. This means we use the integration by substitution twice. Okay, we apply the second substitution to change this one into u. Okay, after that, we integrate the u function with respect to u, then you get this. Then we change the u back into tangent, back into data, and we change the data back into x. Then we get the final answer. Okay. So now I want you to try this one first. Try this one first. Okay, so based on this question, which substitution that you should make to choose? A sine theta. So what is your A? 1. So 1 sine theta. So you have only sine theta. Okay, so start to substitute x into theta. Okay, there we need x squared. So square both sides before you substitute into that function and find the dx. You need to try in order for you to understand the flow of this kind of question. We haven't signed for attendance. Attendance. Take all the x into data. Then try to apply the identity to the 1 minus sine square data to get rid of the square. Okay. So x change into theta, and we want dx. Okay, dx. d theta is cos theta. So dx is cos theta d theta. Cos theta d theta. Okay, 1 minus sine squared. Okay, use this identity. The 1 minus sine squared theta is cos squared theta. Cancel out the square root with the square. You get a cos theta. And multiply to another cos theta, you get cos squared theta.
Simplificar dulu, tapi kamu cerai.
Square root, square, cancel out the square root and square, and then you have cos theta times cos theta, which is cos square theta. Okay, use another identity, cos 2 theta equals to 2 cos square theta minus 1.
Okay. Kalau nak buang square root tu, yang dia satu je lah, yang satu prosedur je lah yang kena buang. Tu kena dua.
What do you mean?
Nak buang sekuasa itu.
This is multiplication. This is multiplication. And this square root, inside square root, you have only cos square theta. The example just now, you have 4 times 1, 4 times cos, right? Just now you have 4 times cos square theta. This is 2 square cos square theta. That's why you get a 2 cos theta. Okay, you have only 1 square now. Okay, so your cos square theta is, move this to the left, you have cos 2 theta plus 1, and then divided by 2. Yeah. This is an identity. Identity. Identity will be given in the appendix. So you have to know how to use that.
Dia dengan saya pun lah pendek.
So you can factorize the path. Factorize the path. Then only you integrate this function. Okay, this one I continue here. Okay, half. So integration of cos 2 theta, you get sine 2 theta over 2. Okay, integrate cos, we get sine. Okay, with the same angle. And then divided by, you differentiate this one, you get 2, you put it here. Okay, plus theta, that means plus 1, that means plus theta. Plus. Okay. Expand. Get a 1 over 4 sine 2 theta. Okay, but this sine 2 theta, I write this one first. Okay, half theta plus c. So this one, sine 2 theta, we use the identity of 2 sine theta cos theta. Okay, you have another identity. I write it here. Sine 2 theta equals to 2 sine theta cos theta. We don't want sine 2 theta. We want sine theta cos theta because here you have the sine theta. Whiteboard is too small. So I use this space. Okay, I want to change all this data back into x. Okay, back into x. So from here, sine theta is x. Okay, sine theta. That means x over 1. So what is your cos? This one will be 1 minus x squared. Okay. I continue here. Here. Okay. Okay, the 2 and the 4, I simplify into half. Okay, this one, 2, 2. Okay, sine theta. Sine theta is x. Okay, this one, sine theta is x. Cos theta is this one over 1, right? This is your cos. Cos theta is this one over 1. Okay, then plus half theta. Your theta is sine x. Then plus c. Okay, any questions?
Sine theta itu jadi aja. Kan jawaban ini kan 1/2 x itu nggak disebut juga bikin ada 3x itu tentang because balik kan begitu nah theta x sendiri kan x jadi
This one, what is the question? This one. This one. Here. Theta is sine x. Or are you sure? Out of line, out of line. No, this is not given as the rank text. Yes.
Tapi itu bukan
To
identity.
another sign, it will be arc. ARC, arc sign. Any more questions? Okay, there. Okay, we proceed to the last one. Okay, actually today I'm not feeling well. But I don't want to cancel the class because we have so many holidays. Okay, this one, integration by part. Okay, this is what you have learned actually. This one I just want to explain, okay, on the formula. Okay, u and v are both functions in x. Okay, u is a function in x, v is also a function in x. So when we have the product of two functions in x and we want to do the differentiation, okay, we will copy, let's say copy the u, we differentiate v with respect to x and then plus. We copy the v and we differentiate the u with respect to x. That's why you have the formula of this. That's why here you get a uv prime plus vu prime. Okay, this is duv or dx. So when we move this dx, this one equals to this now. So when we move the dx to the right, so this one you have a dx. This one you also have a dx. When you have dx, that's mean you have this integral. Okay, so this one when you move, you have only uv. Okay, so from here we just rearrange. Okay, you get this formula for your integration by parts. Okay, now in this course, we will introduce an alternative way for this integration by parts. Okay. Here we rewind on the conventional way first. Okay. For this example, when we want to integrate this, we have the polynomial, we have the exponential function. So we will let the u to be the polynomial function and v prime will be exponential function, correct? Then here we differentiate, this one we integrate. Then we will put this into the formula where we have uv minus the v du. Okay, this one v du. So this one multiplied to this, but with the integral. Okay, then only we solve the integral and we get the final answer. This is what you have learned before you are here, integration by parts. Okay, so if you have this question, x squared. So when you use the first time of the integration by parts, you have this x squared, sine x. Okay, differentiate, you get 2x. Integrate, you get this. So after you put all this into the formula, you get this one, right? Okay, so minus, we get a plus. So now we want to solve this part. And again, we have to apply the integration by parts once again because of polynomial and the cost function. So polynomial, cost function, differentiate, integrate, then you put this uv minus the integration of this one times this one, minus integration of the these two sine x, you get this. Then you integrate this, you get this one, then you get the final solution. Okay, meaning that if you have x power of 5, you have to apply this formula 5 times, right? Now, we want to introduce an alternative way, okay, where you can use tabular method to solve, to replace this integration by parts. Okay, so this is the way you need to have a table. You need to have a table. Okay, so we will identify which one will be u, which one will be v prime. Okay, so the u and v prime, how to choose? It is same as how you choose for this. Polynomial will be u, sine function will be v prime. Okay, then for this u, we will differentiate, we will repeatedly differentiate until we get 0. Okay, this one we will repeating integrate. Okay, and we will stop at the center of this 0. Okay, and this one you need to have an alternating signs. It will always start from plus, minus, plus. So when we want to get the answer, we will use this one times this. Okay, this one times this. Okay, this is the general one. Okay, this is the general one. Okay, u times v, and then this is the arrow. I don't understand the arrow. Okay, ignore the arrow here. Okay. Okay, later I will show you the examples. Okay, now we want to see what kind of functions can be solved under the integration by parts. So basically, there are 3 cases. Okay, 3 cases when you have the product function of polynomial and exponential function. Polynomial and sine, or polynomial and cos, or polynomial and exponential and sine, or exponential with cos. So these 3 types of function we will use integration by parts. Okay, that's mean I will show you this one. Okay, polynomial with exponential, polynomial with cos or sine. Okay, polynomial with cos. This is polynomial with sine. Okay, we can also have exponential with sine, exponential with cos. Okay, the one involved long function, this is a special case where I didn't include under the 3 cases just now. Okay, so when you have this kind of question, we will use integration by parts. Okay, and you can also use the tabular method. Okay, I want to skip all this. We go straight to the example. This one. This one is the same question as, different. Okay, different. That's the same. Okay, so okay, we look at this example. So this is polynomial with sine. So we put the polynomial under differentiation. Okay, sine function under integration. This one you can just write the D, capital D. This one you can just write the I, capital I. Okay, so x squared, we will differentiate. We get 2x. Differentiate once again, we get 2. Once again, we get 0. So whenever this is a polynomial function, you will differentiate until you get 0, then you stop. And here, you will integrate. Okay, integrate sign, you get a negative cos. Okay, with the same angle, divided by this 3. Then this one, integrate once again, this one with respect to x. So negative, you still have negative. Integrate cos, you get a sine with the same angle 3x. Divided by, here you have 3. You will divide another 3, that's why you get a 9. Okay, so repeat, integrate this one with respect to x, you get this. And this one, you will stop at the same row with 0. Okay, then at the first column, you will have this plus, minus, plus, minus. So this tabular method is very simple. You just need to combine this one plus x squared. Okay, that means positive x squared times this one. X squared times this, you get this. Minus 2x times this. So minus, minus, you get a plus. So 2x times this, you get a 2x sine 3x over 9. And then plus 2 times this. Okay, plus 2 times this 1 over 27 plus 3x. And then plus c. Okay, so this one, if I repeat this with the previous example just now. Okay, tabular method is very, very user-friendly. You see, when we want to integrate this one, x squared sine x, and we just need this. Okay. And let's see what is the difference. Differentiate, integrate. So polynomial with sine or polynomial with cos, we will always choose the polynomial under differentiation. Okay, so we will differentiate this one with respect to x, you get 2x. Once again, 2. Once again, 0. So plus, minus, plus, minus. So for this side, integrate, we get negative cos. Integrate once again, negative sine. Integrate once again, positive cos x. Okay, that's this one with this one with this one with this. But you have to take together with the sign. So positive x squared, positive x squared times this, you get a negative. Negative x squared cos x. Then minus 2x times this multiplier. So minus minus, you get a plus 2x sine x. Then plus 2 times plus x plus c. You get the same result.
Kalau positif itu dia akan panjang lah.
X cubed, that's when you have one more row. Okay, so this one, you don't have to repeatedly use the uv minus v, the integration of v vdu. Okay, this one, you can get the answer very fast. And you will need this for next semester for the subject of differential equation, especially for the topic of the Fourier series. You will use this massively. So make sure you know how to use this tabular method. Okay, this tabular method is we can replace the integration by parts. Okay, now we're back to the slide. Okay, next one, when you have exponential, polynomial with exponential, Polynomial will be under differentiation, exponential under integration. Because integration, you can't differentiate until 0, right? Only polynomial you can differentiate until 0. And okay, this one. Oh, I haven't shared the screen. Okay, back to this. Why we stop here? Okay, why we stop here? Because suppose we need to continue. 0. Integrate cos, we get sine, right? If you continue again, integrate sine, you get negative cos. But what's happened when you have this? 0. 0, 0, 0. So useless to do this. That's why we stop here. Okay? That's why we stop here. We stop when we get 0. Because we know that 0 multiplied to anything, we still get 0. Okay. Okay. Next, this one. Okay. Polynomial with exponential. So differentiate until you get 0. Integrate, you get this over 2. Integrate once again, you get over 4. Okay. Then finally, plus x times this, you get the first component. Minus 1 times this, you get the second component. And then plus c. Because we know that 0 multiplied to the next, it will be 0. Okay, another example. Okay, this one is special. Okay, this is the third case where we have the exponential with sine or exponential with cos. This one, we do not have polynomial. Because here, when you have the polynomial, you are able to differentiate until you get 0. But for exponential or sine or cos, we can't get 0 no matter how many times you differentiate it. Okay. So this one, you just compute for 2 lines. Okay, 2 more rows. Okay. You can either choose sine x here, exponential here, or exponential here, sine x here. It doesn't matter. It will give you the same answer. Okay. So this one, work out 2 more lines. Okay. Because if I back to this. Okay, this one actually we can let's see what's happened if we stop here. If you work out this, and this, but you didn't work out the last line. Okay. So this one with this one with this, the one horizontal, okay, the one horizontal, we can also multiply this one. That means, let's say we work until this. If we work until we stop here. So this is horizontal row. Okay, so we can use this one multiply to this. We take together with this side. Okay, so you see this one integration, we get this one times this, we get negative x squared plus x. This one with this, negative, we can call these 2x sine x. And for the horizontal row, minus 2 sine x, minus 2 sine x. But the one from the one that you take from horizontal row, you have this. So what's happened? Minus 2 integrate sine, we get a negative cos. Negative cos, negative, we get plus cos x and then plus c. So same as this. Okay, so the one horizontal row, you need to insert the integration sign. So this will be used when the function under D, when you can't get to differentiate until 0, then we have to use the horizontal row. Okay, but this one, because this one we can get 0, so we just proceed and we can get the answer directly. Otherwise, yeah, you can stop here. You need to solve this one more. Okay, one more line. Okay. Now, I want to show the example just now that involved the exponential and sine function. This one, e pi x sine x. Sine x sine x. Okay. So this one, okay, I choose this under D, this one under I. Okay, you can also swap the two functions. Doesn't matter which one under D or I. For the third case, okay, for the third case, exponential sine or exponential cos. Okay, then we work out two more rows. Okay, we work out two more rows. This one differentiate. What do you get? Sine e pi x. One more. Pi square e pi x. Okay, integrate sine. Integrate negative cos. Negative sine. Plus minus plus. Okay, so this one, and then this one. Okay, so this one, okay, it's equals to negative e pi x cos x, and then minus, there's a plus pi e pi x sine x, and then horizontal row, we have minus integration of pi squared is a constant, e pi x sine x dx for the horizontal row. Okay, so we can factorize this constant outside the integration. Then we get this. Okay, then on the left, we have this. On the right, we also have this. They are the same, right? They are the same. So we can move this one to the left, combine with this. This term move to the left, combine with this. So when you move, you have this plus equals to these two terms. So far, okay? Then this one is the same with this. We factorize. We factorize this one. So what is that? 1 plus pi squared. Right? Factorize these two. Factorize out, you get 1 plus pi squared. And on the right, still have the same function. And finally, Okay. So when you have exponential with sine, exponential with cos, you just work out two more lines. The last one, you use horizontal row. Whenever you use horizontal row, insert the integration symbol. Okay, and this one for sure, you will get the term which is same as the question. You just move it to the left, combine, factorize, and this one you move to the right, then you will get the answer. Okay, any questions?
Mulai by x sin x sama dengan by x cos x.
Huh?
Lain dengan
1, 2, 3. This one.
No.
This one. This one, left hand side equals to right hand side. You have 3 terms. Where the third term, this one is the same exactly with this. So we just move this one to the left. Then we factorize the same term. Okay?
So just put
Whenever we use the horizontal row, you need to insert the integration sign. Okay, so we proceed to the exercise. Okay, this one, which one is B? Which one under B? X cubed.
Yeah.
Okay, differentiate until you get 0. Complete the table. Then get the answer.
Yeah. Banyak betul lah.
Ini
The final answer is already given in the slide. Answer is number one.
Đi qua trên tập quân năm là đều biết gì phải một vậy tại phải cô phải xin phải nó cũng không ra còn không cho em phải xin phải tiếp tục sẽ tập quân sẽ chụp police thì nó là không
Jadi di 16 ini boleh saya apa?
quay lại chờ riêng sự đó thì có chỗ là tâm nguyện địa
Any questions? để ngày cái US tính chính nhỉ
Jadi di heads today kita ada activity events. Nanti dia kelas oh betul. Jangan maghrib kan? Cakap korang hidup cari terbaik itu sampai itu lain. Albert jadi kerja. Dia punya muka lima dia dah terbalik sekarang. Oh, iya lambat ya. Pendek tak? Betul. How you get 3x? 3x minus 2 cepat. Cepat.
To find. Even if to find. This one multiply to this.
You simplify dulu tak boleh tak. Biar masuk. Ini nomor 3 kan.
Permukaan dia.
Okay, any questions? Number 5 and 6 are under this three. Phase 3, where we do not have polynomial function to be differentiate until 0. This one, you just first produce another 2 rows, then you have to manage the horizontal row. You insert an integration sign. So for number 5 and 6.
Jingle bells,
Okay, number 4, done. Okay. Number 6. And number 5. Okay, move this to the left, combine with that one.
Mana? Si dah pandai. Sekarang dia jauh. Ini juga misalnya dia juga bilang kucing lagi. Pada video ini. Bukan. Dia pusat. Dia punya style tak? Tak ikut, tak apa mau ini juga. Kalau kata. Oh, this profile here.
Masuk dalam
Ini bila row, kita ambil row E sin 3x. E sin 3x. Okay, so when you have this case, we just need 3 rows, okay, because no matter how, we will stop with the horizontal row, okay, where we will get exponential sin 3x, which is same exactly as the question.
I will get one.
One. This is 1. 1 unit, right?
Dapat dari juga. Apa?
Ini adalah 1 durian. Ini adalah negative 4/9 durian. Oh ya,
Kata keluar dulu ya. Apa namanya? Loiper tak?
Okay. So question number 6 is similar. Okay, number 6 similar. Can you do it on your own for number 6? If you understand this one, suppose number 6 shouldn't be a problem because number 6 is similar to number 5, where you need to give 3 rows and move this term, which is same exactly with the question. You just move the term to the left, combine, factorize, combine, and then you move this to the right. And remember to put a plus C for your final answer. Okay, if this is not given, the limit. Okay, now I want you to look at the last question, number 7, because number 7 involves the non-function. Can I have this one? Okay, make sure you complete the question, number 6. Okay, now we look at number 7. Okay, now look at the whiteboard. Okay, last question. I'm sure all of you hungry, right? That one. X sin x1 x. Which one should be under D?
X. Lon.
X under D. Ln under integration. So how to integrate ln?
1/1
That is differentiation, right? We are unable to integrate ln x. When you differentiate ln x, you get 1/x. So differentiate ln x, you get a 1/x. Integrate this one, you get a x²/2, right? Integrate x, you get x²/2, right? Differentiate ln x, you get 1/x. Okay, let's say we use only 2 rows. Okay, we use only 2 rows. So from the horizontal row, okay, from the horizontal row, when you multiply these 3, you get x/2, right? You get x/2. Are you able to solve this x/2?
As 1/2 coming into X.
Yes, that's mean 2 rows are enough. One over x, x²/2. Okay, plus c, yeah? x²/2 ln x minus, so this will be 1/2 x dx. Okay, that's mean x²/2 plus c. 1/4 x² plus c. Okay, so for the tabular method, actually where to stop, for the special cases, where to stop, you just look at the horizontal row. Are you able to solve this? Yes, then that means that is enough. If you want to work on one more row, yeah, sure, no problem. You will get the same answers. You get 5. If you work for 3 rows, if you have 3 rows, then you use the horizontal row from the 3rd row. Okay, so this one with this one with this, and then horizontal row, you will still get the same thing. Okay. Okay, so that one I leave it for you to try on your own, to explore it. So we stop here for today. Okay, any more questions before we end the class?
Not yet.
Okay.